Before I start graphing linear inequalities for section 4.6, I want to do a quick little bit of review of just graphing a single inequality. So this should be graphing, oops, it should be 3x minus 2y is greater than or equal to 7. Alright, if I wanted to graph this, remember that when we were graphing these, we pretend this is an equal sign first. So 3x minus 2y equals 7. So for the first part of graphing this, I'm going to just replace it with an equals. And to figure out where the boundary line is, I'm going to put this into slope-intercept form. So negative 2y equals negative 3x plus 7. I subtracted 3x from both sides there. And then I want to divide both sides by negative 2, giving me y equals 3 halves x, because I'm taking a negative 3 divided by negative 2. That gives me a positive 3 halves, minus 7 halves. This number, this is my y-intercept. So if I'm graphing this, let's see, 1, 2, 3, 4, 5. If I'm graphing this, I need to figure out where negative 7 halves is located on my number line. And, well, you can just ask your calculator if you want to convert it to decimal. You can see that's 3.5. Well, negative 3.5 because it's a negative 7 halves. So 1, 2, 3, and a little bit further, a negative 7 halves, since that's the x-axis, I don't know why I'm going there. 1, 2, 3, and a little bit further would be right here. That's my y-intercept. Now to find another point on the line, I could go up 3, 1, 2, 3, and to the right 2. Just like I would expect using my slope-intercept form. Now, of course, this 3 halves, you could think of it as 3 halves over 1. In other words, going up 3 halves, that's up 1.5 up to here, and to the right 1, which gets me to an integer coordinate. This would be the point, looks like 1, negative 2. It can be kind of handy, especially if you're trying to graph this thing on the computer. To find integer coordinates, you might have to step weird sizes like that, or just try out different values. If x is 1, does y come out to be an integer? If x is 2, does y come out to be an integer? And so on. So you can see my line, regardless, is going to be right along here. In order to figure out if it's going to be a solid line or a dashed line, I do consult the inequality here. This is a non-strict inequality, which means it's going to be a solid line. So I'll just draw that in here. Clean that up a little bit. Alright. And I need to figure out which way I should be shading. Now, I don't want to use my equation here because I've lost any sense of direction, which side I'm talking about. I want to go back and test my original, the original equation, this one up here. So if I'm going to test a test point, it can be any point that's not on the line, so my favorite is the origin. If I do 0 plus 0 is greater than or equal to 7, you know, like I said, my favorite point is the origin because I like plugging zeros in for both x and y. 3 times 0 is 0, 2 times 0 is 0. We just get 0 on the left-hand side of this equation. And this is a false statement. 0 is not greater than 7, which means that this point, the origin right here, does not satisfy the inequality. So it should not be in the shaded region, which means we're going to shade the other side of the line. We're going to shade down here. So that's a quick review on how to graph a single inequality.